In stratified random sampling, the second theorem is variance of y bar st, that is variance of sample mean in stratified random sampling, is equals to summation I is equals to 1 to k 1 by small ni minus 1 by capital Ni into pi si square. Here there is a new term, that is pi. Pi is in proportion here. Pi is equals to ni by n, which is the weight of the ith stratum. We can say that weight of the ith stratum is basically the importance of that particular group of data, like that particular subgroup of data. That's it. There is nothing in depth about this. So we'll move on to the proof. Y bar st, we already know the formula. Y bar st is equals to 1 by capital N summation I is equals to 1 to k ni y bar ni. Here it is asked to prove the variance of this particular formula. So we will apply variances on both sides. Variance of y bar st is equals to variance of 1 by capital N I is equals to 1 to k ni y bar ni. Now we already know the n and ni are constants here. N and ni are constants here, and the variance of a constant, it usually becomes square when it comes outside. So 1 by n square, it came outside, the constant became square, 1 by n square summation I is equals to 1 to k ni will also become square, ni square, and variance of y bar ni, they became squares, and we applied variance to this, the only term there. Now from SRSWR, by the way, SRSWR is almost similar to stratified random sampling in some ways. Basically they are equal in like variance or whatever we may consider. So variance of y bar ni will be the same as variance of y bar n from simple random sampling without replacement, not with replacement, without replacement. So 1 by n square summation ni square variance of y bar ni. So y bar n, we already know the simple random sampling without replacement variance is n minus n by n s square by n. That's it. We already know this. Variance formula that we already proved. So we will take this variance and we'll substitute here. The variance of y bar n is equals to variance of y bar ni. Basically, this is what we should put in mind. So from a previous theorem, here it is ni, right? In variance of y bar n, it will be simply n, and we'll use small n here. Here when we come to the stratified random sampling, we will add the ith term there. Like it is basically indicating that this particular bit of sample is taken from a stratum. That's it. It is from a stratum and not from the entire population. That's it. So 1 by n square summation I is equals to 1 to k ni variance of y bar ni, that will become ni minus ni by ni into s square by si square, that is because this is also part of the stratum, s square by ni. We can cancel this n and this 1 square here, and 1 by n square I is equals to 1 to k ni minus ni si square by ni, si square by ni. Now let's take ni common in this term. Let's take this ni as a common term, the capital Ni. So what will happen? 1 by n square summation I is equals to 1 to k. Here the ni that's already here, we are writing it here. The ni that's already here, we wrote it here. Now the ni that we are taking common, we'll write it here. Ni we already took common, so 1 minus ni by n, because there is no ni in this term, and if we multiply ni again to ni by capital Ni, the ni will cancel and we'll have the small ni. That's it. Into Si square by ni. Si square by ni. Now 1 by n square. This now all we have to do is just basically simplify this to achieve this. That's it. We have to simplify it to achieve this. 1 by n square summation I is equals to 1 to k ni square. Now if we take this n inside 2, so that would become 1 by ni minus ni by capital Ni into small ni si square. Now if we basically simplify this even further, let's keep these other terms aside. If we simplify that inside term further, ni square, we have, so basically what do we have to do here? If we multiply capital Ni here, capital Ni into small ni is ni minus ni si square. That's it. This is basically, we took LCM here because we don't have an capital Ni here, so we multiplied ni here and ni on the top too, so ni minus ni by si square. That's it. So if we take this ni square, if we take this ni square here, that is ni square by ni square, summation also applies here, so I is equals to 1 to k, and ni minus ni by n si square. So we already know that capital Ni by n is equals to pi. N, it is the weight of the stratum. And if we take simply, if we just take this as whole square term, summation I is equals to 1 to k ni by n whole square into ni minus ni by ni si square. So this is basically p. We already know this. From here we know that this term is p. So variance of y bar st is equals to summation I is equals to 1 to k pi square, because there is a square outside, so ni by n is equals to capital Pi, and there is a square outside, so it became pi square into, it is, we got a capital Ni minus Ni by Ni. So if we basically write it in a different way to fit our proof, we can simply write it as 1 by Ni minus 1 by capital Ni, and there is a si square outside. And if we wanted to write exactly how how we need our proof, then summation I is equals to 1 to k 1 by ni minus n 1 by ni pi si whole square. This is the variance of y bar st that we needed to prove. This is what we required to prove. This is what we were required to prove. That's it.